Hello and welcome. This is Joel from our marketing team. In today's episode, we will take a deeper insight into our system MetalMaster. And with me today, I have Ammar Seidinoski, who is Customer Success Manager within Metallurgy here at Novacast. Very welcome, Ammar.
Hi, Joel. Thank you very much for the invitation.
We will speak a little bit about MetalMaster today, and the latest version of MetalMaster was launched in December last year. How would you describe the system MetalMaster to those people who haven't heard about it before?
So, MetalMaster essentially is a charge and correction optimizing tool based on the foundry's internal quality requirements. The aim of the tool or a software is to reach the targeted chemical composition for a specific quality to the lowest possible cost. So that's, in a simple words, the aim and the purpose of the software called MetalMaster itself.
Yeah, and what opportunities does MetalMaster bring to the foundry industry, would you say?
Well, first of all, I have to say that a MetalMaster is an easy to use software which can optimize a foundry's charge in a matter of seconds. So that's very important for every foundry. With the latest version, which is 5.3, we implemented a new feature called a CO2 calculation, and with that feature we can basically, our customers, let's say, have the greenest charge at the lowest possible cost. Beside that, the MetalMaster can easily be used as a support system to aid us MetStar, which is our premium metallurgical process control software.
Yes, and in the latest 5.3 version of MetalMaster, you were mentioning it a little bit about the CO calculation. The CO2 calculations of each batch can be executed. Can you tell us a little bit more about that?
Well, speaking about the CO2 calculations and emissions, nowadays those, especially European laws, becoming more strict and strict regarding this topic. Therefore, and each material supplier should provide a CO2 emission factor for each material which they are selling. So in our MetalMaster we have a feature where we basically input this data into the materials menu, and we have to have it there in order to be calculated in the end. So that's why it is very actually important to keep in mind that regarding the CO2 calculations, it's not actually calculating the melt CO2 emissions, but the charge CO2 emissions based on the materials input. So that's really important to remember.
So would you say that MetalMaster and the version 5.3 is a game changer in the foundry business when it comes to sustainability?
Yeah, I mean, speaking from that perspective, I really can say that MetalMaster is a game changer in the foundry's business or industry due to, let's say, already aforementioned reasons which I stated before.
Yeah. And what kind of industry would you say that MetalMaster primarily targets? Is there any specific target group?
About the specific target group of the industry, I cannot say that at the moment that MetalMaster has, let's say, a primer industry except the foundry industry, which is of course also very widespread. However, our customers are mostly suppliers for automotive industry, manufacturing industry, etc., etc. So yeah.
This sounds very interesting, Amar. So now we will take a look and a demo session into the program MetalMaster.
Let's see it.
Hello everyone and welcome to our new NCTV episode. Today we will have a quick guide through our MetalMaster 5.3, which is the newest version. We will have, as I said, the quick guide through our optimizer module in MetalMaster. Besides that, we will also have a quick insight to our newest features of the version 5.3. So let's get started. First of all, one of the biggest features and newest features of our latest version is a CO2 emission feature. We will find that feature in the materials menu, where we are selecting and checking each material for our charge optimization. As you can see, you first need to name it, you put the price on it, and then it comes the newest feature, which is CO2 emission factor. So for each material, you have to add this CO2 emission factor if you want to have it calculated at the end of the optimization. That's more or less it about it. It's for some of those materials, they have already, let's say, pre-added CO2 emission factors, because we tried to investigate a little bit and we found out from IPCC 2006 that the CO2 emissions factor for some materials are already prescribed, but of course, please have in mind that you have to always contact your material supplier for the CO2 emission factor, and that would be the most accurate value of your CO2 emission factor material. So if we go to the optimizer module, of course, the first thing which we need to do is to name it. And for example, we will have today the name of NCS. And then you will need to select one of those types, charge or correction. If you want to do a charge, that means you are doing a base metal and the first, let's say, the first melting. If you want to do correction, then that usually means that you have already some of the metal inside your furnace and you want to do a correction of it to some limit or some furnace capacity. Then you have the target weight. If you have predefined furnaces here in the furnace and ladle editor, then you can simply select here name of the furnace, which is easy, or you can manually input the target weight. After that, you have the alloy selection. The alloy selection means that you want to choose from the alloys which you want to optimize. So usually the base alloys are for the charges, and then you have the final alloys for the correction itself. So for example, for this example, we will use the European norm 250 lamellar base iron. And then we simply click the optimize. Of course, for after your installation of the program and after the first setup, of course, you need to define all the materials in the materials menu, which you are usually using, and then you need to go to your charge optimization, to charge compositions, and then of all those materials, you need to select which materials you want to use into your optimizations, whether is that charge or correction itself. You can simply name it, your charge compositions here, and you can either choose, do you want to have weight or the percentage for your limits in the materials. As you can see here, for the base returns, I put that the minimum is 400 kilos and the maximum is 1,200 kilos. And for the pig iron, I put the limits between 100 and 300 kilos. That's simply because of those experimental, let's say in a way, test optimizations, but you can have it differently according to your foundry specifications, etc., etc. Of course, you will see that later on during the optimization. Even when you get the optimized results, you can change these things manually in the optimizer module itself. So let's get it done. So simply we just click optimize, and then here is our optimized charge. So you can see here that the amount is 4,000 kilos, as we said, 300 kilos of the pig iron, then the steel base returns 1,200 kilos, and the other materials. You can here in the results see that we have 30% of returns and 57% of the scrap. The environmental melt index is 71. That means that our CO2 per kilo is over 1 kilo. We have the cost per ton, cost per kilo, cost per charge, and CO2 emissions per ton and per kilo, as I said beforehand. Here you can see that according to our specification and chemical composition, all chemical elements and the charge is within the limits. However, the carbon equivalent is not totally between minimum and maximum. Therefore, you can here click that you want the correction according to your carbon equivalent. If we click on that, then suddenly it will all be calculated according to that, and you will have here a bit of the slight difference. And as I said, this is the optimization by the cost. You can see here that you can optimize your charge by cost and by CO2. You will see now that if I click on the CO2, we will have here some slight changes, which are quite natural. For example, the cost per ton now is 480 euros. And if I click on CO2, the cost will probably go up, which is here also the case. That's because now the system is using the greenest materials for the charge and not the cheapest. So that's quite normal that the cost per ton is going up. And you see that here now the CO2 per kilogram is 1.13 instead of previous when we had optimized by cost, which was 1.22 kilos of CO2 per kilogram of material. There's also one information which I would like to share. You will notice also here that the total weight is 30 kilos more than the amount of the weight which we inserted at the beginning of the optimization. That's because we have, of course, let's say the products of the burning in the metal, and that's quite normal that we have the dross generation and, of course, the burnouts within the furnace itself. Therefore, we have always a slight increase of the total weight in the furnace instead of the, let's say, exact amount which we insert. That was all about charge optimization. Besides that, I will also show you here what I mentioned in the materials menu. So basically you can put here, you can delete those limits. And if we do that, you will see that it will go into the different optimization. You see, now the system is using the almost everything from the base returns, because base returns are often made as a cheapest material because it's the products of the foundry itself. Of course, in the reality, that's not always the case. Base returns are not literally having the zero cost. Here it's 0.5, but nevertheless, it's still the cheapest material and the most convenient for the charge itself. Therefore, now the system is using almost 90, it's not almost, but 98% of it for the charge itself. But if we have a limitation, as all the foundries has, that is quite not normal to be 30 to 40% roughly. And of course, all the foundries want to have some percentage of pig iron inside, and more or less this is the normal charge optimization. Besides that, we have also a way to print this, so we can directly connect our MetalMaster to the printer if you have it connected, and then we can print it. Then there are the calculated melt properties, where you can see the gray eutectic temperature, white eutectic temperature, and a lot of other informations regarding your charge. You can have a small notes, so you can basically write whatever you want to write here. For example, charge optimized for the purposes of NCTV episode, and you can save and close that, and simply here on the X you close your optimization. Then we can switch to the correction, and now we have a heel weight. So the heel weight is something which is already in the furnace or the ladle capacity, whatever. And if we say, okay, now we have a heel weight of 1000 kilos, and we switch to the final alloy, I now choose the nodular 400 European norm final iron. And let's go just for the optimization. Now you see that we have here the optimized view, and here you define the weight. Of course, you have to select the material, which is usually you have already some spectrometer readings from that, and then you select your material here. You can input it even manually, and then your optimized charge or correction, let's say, is here. You will see here that the CO2 per ton is 0, and that is because one or more materials doesn't have the CO2 factor, and that is here the last material. So that is the one really important thing. If you want to have a CO2 emission factors of your charge calculated, all the materials selected have to have their emission factor defined in the materials menu. Therefore, you will see here, this is the material, and you see that it doesn't have any emission factor. But if you go, for example, into the correction and you deselect that material, of course you have to save it, then you can go back to your optimization and update it, and now we have it calculated. So this is also optimized by the cost, and if we switch to the CO2, we will have a slight difference. Of course, we can also do the CE, carbon equivalent correction here, and you see now the environmental melt index is 100, which is the best score which we could have. And you see the 7 kilos is over the weight which we wanted to have, but that's because of the reason which I mentioned before. Of course, you can have for this the same printer, calculated melt properties for your corrected melt notes as well. And yeah, now I will just show how you can open your previous optimization. For example, the one which we put the note on it, you can see it here, charge optimized for the purposes of NCTV episode. So basically you can see here instead of new, so if you go to the new, you are doing a new optimization. If you go to the open menu, then you are opening your previous optimization. So if I open this, you can see the optimization which we made just a couple of minutes before, and here is written as this object is currently not editable. So basically this is a kind of security switch where people cannot make any kind of changes after the optimization is done. However, it can be editable just on this click. Just if you click on this make editable button, and now you can edit and play around whatever you want, as it is a normal optimization and new optimization. So yeah, that's more or less everything from my side. I wish you a very pleasant and the rest of the day, and please stay tuned for the more and the next NCTV episodes. Thank you very much for attention, and yeah, take care. Bye bye.
So finally, Amma, companies who are interested in our system MetalMaster, how should they proceed?
Well, I would say the easiest way is, well, let's say there are 3 ways to do it. So first of the way, which is the easiest way, if they know us personally, for example me, they can directly contact me on my email or my phone number. The second option is to contact us via support@novacars.sa, and the third option is via our partners worldwide. So you can find the list of all our partners on our company website, www.novacars.sa. In that way, we can proceed and process inquiries very quickly and help out our potential customers in the best way and which is the most suitable for them.
Sounds really good, Amar. And I want to thank you, Amma, for participating in this NCTV episode, and thank you very much for sharing interesting thoughts and reflections about our program MetalMaster.
No, thank you, Joel. It was my pleasure, and yeah, thank you for having me here.
Thank you. And this was all for this NCTV episode. But we will be back with more information and more content regarding our products and services. So thank you very much for watching this episode, and do not forget to follow us at LinkedIn, Facebook and YouTube. Take care everyone. Bye.
Bye bye.